Hello everyone, and welcome to this part of the Module 7 where we will look at how to mesh the bevel gears and also learn how to mesh the rack and pinion. The difference between the bevel and the meter gear is only from the speed ratio point of view. Although these bevel gears belong to the class of intersecting axis, the meter gears are only used when the shafts are not parallel to each other and the power to be transmitted is in the different axial direction than the parallel axis category. The speed ratio is 1:1 for the meter gears. So we're going to be doing the example on the bevel gears, and we will be designing that from the macmaster.com. These are some of the parameters for the gear and the pinion that we will be designing for the purpose of assembly. So we're going to take the face width for both gear and the pinion equal to 0.19 inches. Remember, these are the inches system of units for the gears. The smaller gear in this assembly is a pinion and the bigger diameter is the gear. The diametral pitch is 16 for both gear and the pinion. Pressure angle 20. The speed ratio will be 2:1, which means that the number of teeth for the gear is going to be double that of the teeth on the pinion. The rest of the parameters we will take it from the macmaster.com. And also notice the cost of making these bevel gears, which are expensive as compared to the spur gears. So the important parameters here is to look at while designing the plate and the shafts on which these two gears are going to be mounted are the mounting distance for the with respect to the gear, the mounting distance with respect to the pinion, which is B. Also the face width, we're going to keep it same for both gear and the pinion, and also the hub width is important to note so that the plate can be design and the holes can be created accordingly. The shaft diameters are different for both gears and pinion, as you can notice here. A half-inch diameter is for the gear and 3/8 shaft diameter is for the pinion. So we're going to have two different shafts, one for the gear, the other one for the pinion. And then looking at the hub width distances, we can design the plate accordingly. So let's go to first macmaster.com and then type the search options as gears. Once you open the gears, there are several categories of the gears here. So I'm going to choose this option, metal gears for changing direction, and then click on the bevel gears. So some of the standard available bevel gears are shown in this page. We can customize and select the one that we want, but for this example I'll be choosing the first option for the gear and the first option for its compatible pinion. So as you can notice from the input parameters that we want for the gear as well as for the pinion, we can select these gears and pinions and then click on the product detail, and once you scroll down, then we can click on the save to save this bevel gear as well as the pinion. So once we've saved these two parts, then let's go to SOLIDWORKS and let's open the plate first. In the interest of time, I have already created the plate with the holes as per the shaft diameter for the bevel and the for the bevel gear and the pinion assembly. So remember, the pinion is 3/8 inch diameter, so that's that, and half-inch diameter shaft diameter for the gear, so that is already been created at appropriate distances so that a perfect assembly can take place. So based on the dimensions as shown in that previous slide, you can design your own plate and then drill the holes accordingly at the distances as required based on the mounting distances for both gear and the pinion, as well as considering the hub width for both the gear and the pinions. Alright, so now I'm going to make assembly from this part and bring it in the assembly. Then I'm going to insert the components, and for inserting these components I'm going to use the shaft A, the shaft B, as well as those two gears which we have downloaded it from the macmaster.com. So I'm going to place one by one these items in this assembly and then start assembling it. So the first thing I'm going to do is click on the mate and then place these shafts in the locations where the holes are drilled. So first thing I'm going to do is align their axis, and then after that I will be mating the gears. So for that, again, I will be assigning the shaft concentric option, but here you would notice that the gear is attached in the wrong direction, so we can always use this mate alignment option so it faces in the correct way. Click OK, and the same thing for the gear. Again, I notice that it's in the wrong direction, so I'm going to use the mate alignment and then click on the check mark. Now the next thing that I will be doing is align the front face of the shaft with the face of that gear and the pinion. So after that alignment is done, the next mate assembly that I will be imposing is the distance of ½ inch from the end of the hub to the face of this plate, because that's how the way I've designed this plate with holes in it. So I'm going to click on this face and then bottom of that hub, and then I'm going to use the distance option to assign 0.5 inches, but I need to first make sure that I'm in the inches system of units. So I'm gonna go back, come out of this mate mode and change the units to inches, and then redo this assembly. So let's go to mate, click on the back face and then the face of the plate, use the distance option and then plug in ½ inch, click OK, and the same thing I'm going to be doing it for the gear side as well. So the plate and the face, again use the distance option and let's plug in ½ inch. I'm going to click on the check mark and make sure that the gears are not, the teeth are not interfering with one another. Otherwise we can just slightly move this to clear that interference between the teeth of the gear and the pinion. So now I'm going to go to again the mates, and then this time I'm going to go to the mechanical mates and then click on the gear. And I'm going to select the gear first and then I'm going to select the pinion. So for selecting the gear, if I click here and try to make sure that it's selecting the edge of the gear and not the edge of the shaft, and then the next selection I'm going to do is this pinion, but if I move my cursor there, it says boss extrude, which means that it's trying to select the shaft, which I don't want. So I'm going to right click there and click on select other, and then make from these multiple selections what options that you want to choose. So obviously we don't want to choose this edge of the shaft which was showing it earlier. So what we want to do is select the edge of this gear. So I'm going to select that and then put the ratio here, which is very important. So we have designed this by 2:1 ratio, and the fact that we need to put this as 2:1 because we've selected the gear first and then the pinion. So whatever the RPM the gear is rotating with, the rotational speed of the pinion is going to be doubled because of the number of teeth on the gear are twice the number of teeth on the pinion. And since we've selected the gear first and then the pinion, the ratio of 2:1 is assigned here. If we had selected the pinion first and then the gear, then we would have put in 1:2. Okay. So once we've done with this, then click on the check mark, come out of it, and just try to move to make sure that the assembly is working correctly. Okay. So once we see that the gears have been meshed accurately, now we want to see if the motion has been transmitted to the shafts as well. So if I try to move this shaft, it's not really moving, either the gear or the pinion, because even though the gear or the pinion are mounted on these shafts, they're not really connected from the animation point of view. So in order to make that happen, what we need to do is again go back to mate, go to the mechanical mate, click on the gear, and this time I will make the selections of the outer circle of the shaft and the circle on the gear, and make sure to assign the ratio of 1:1 because they are mounted on the same shaft. So if there are multiple gears mounted on the same shaft, all the gears are having the uniform rotational speed irrespective of the number of teeth, and so therefore we're going to make it as 1:1 for anything that is rotating on the same shaft. And once we do that, then I'm going to click OK. And now if I try to see if that has worked, so if I now try to move the shaft, now we can see that both the gear and pinion are engaged. Okay, we can do the same thing for the other side on the pinion, and let's go to mate, go to the mechanical mate, gear. I'm going to select the shaft circle there and the gear, and also this time I'm going to assign the ratio of 1:1. Then click on the check mark, and now if I try to rotate that, you can see the pinion is rotating and the gear is also rotating. Okay, so that is how the power can be transmitted from one shaft to the other shaft by using the bevel gear mechanism. In addition, if we want to make sure that the shafts are rotating, then we can try and modify the features on one of the shafts. For example, I can go to this one particular shaft mounted, the pinion mounted on it, and I can open the part. And once the part is opened, I can make use of the right plane. First, I can create the plane, and let's say I make a plane parallel to the right plane, and I sketch on this plane, let us say a rectangle. Click OK, and if I come out of this and then go to features, use the wrap feature, and click on the sketch, and then for the face, let's say I choose the cylindrical face, and then use the scribe option, and then click on the check mark. So that rectangular sketch has been created on the cylinder. So if I click on it and try to color it with let's say a different color, and then click OK, just to put a mark on that cylinder, and then come back to the assembly. Click OK. You can see that it's showing the error because it's probably missing some information because of the modification here. So in this coincident option seems to be the problem under the mates. So we can right click, again edit feature, and it says it's missing the face for the coincident. So I'm gonna right click on that missing face, delete it, and one more time I'm gonna make selection of that face, then click OK, and then come out, and so that error is fixed, and again we can see the assembly is working fine. So these are some of the kinds of markers that you can add it on the rotating components if you want to make sure that indeed a rotational motion is taking place. So now if I try to rotate this shaft, I can see that the other shaft is also rotating. So that is the bevel gear assembly to transmit the power in the intersecting shafts which are non-parallel. In the next example, we can take a look at the rack and pinion. So for the rack and pinion, again, this is an example of the gear made where we have a pinion as a spur gear, and then we have the rectangular rack where we have a linear direction teeth, and the rack and the pinion are assembled together in order to have a translational motion based on the dimension of the rack. So we're going to do the assembly for this, and this time we will be designing these parts from the SOLIDWORKS library. We will be using the face width of 1/2 inch. Let's keep the diametral pitch of 24, pressure angle 20. The number of teeth on the rack depends on how many teeth that we can get in the 6-inch length dimension. Of course, we can easily count the number of teeth based on the diametral pitch, and on the pinion we will consider 30 teeth, so that the pitch circle diameter for the pinion is going to be number of teeth divided by the diametral pitch, which is equal to 30 over 24. That equals to 1.25 inches. So the pitch circle diameter of the pinion is 1.25 inch. Shaft diameter is 1/2 inch, and hub is on the one side, and the overall length for the rack is 6 inches again, and the pinion is 1 inch, which means the face width is 1/2 inch and the hub width is 1/2 inch. So the together included overall length or the overall width is equal to 1 inch. So these are the dimensions for the rack and the pinion. And now let's go to SOLIDWORKS to start designing this assembly. In SOLIDWORKS, let's go to design library, let's go to ANSI inch after we install the toolbox, then go to power transmission, gears, and then the spur rectangular rack. So I'm going to right click, create part, and input the toolbox parameters as what we want to design with. So starting off with the diametral pitch 24, pressure angle 20, 1/2 inch face width, 1.5 inch pitch height, length is 6 inches, and that's all the information you need for creating the rectangular rack. So I'm going to click on the check mark. Also, I'm just going to color this and then click on the check mark. The next thing I'm going to do is click on the spur gear, create part. Using the diametral pitch 24, number of teeth 30, pressure angle 20, 1/2 inch face width, one-sided hub. The hub diameter is 1 inch, and the nominal shaft diameter is 1/2 inch with the overall length of 1 inch as we wanted. So again, I'm going to click on the check mark to complete that part. And so once we have this spur gear, then we're going to start assembling these two items together. So I'm going to again go back to the rack and then start the assembly from that. So once I click make assembly from this, then click here, insert components, get the spur gear, and the first thing, again, just for the assembly, we're going to go to the mate and then align the front face of the pinion with the face of the rectangular rack. I'm going to use the mate alignment to turn it around and then click on the check mark. The next thing that we will need to do here is let's orient this in the front view orientation, and then I'm going to slightly bring this down so that there is no teeth interference. Then I will use again in the standard mate the rectangle on the rack to make it coincident with the rectangle or the top land on the pinion, and then click on the check mark, click OK, and then come out of it. Again, I use Control 1 to orient it and make sure that we don't have a situation where the teeth are interfering with one another just from the visualization point of view. Not that the assembly won't work, but it just looks good from the visualization point of view that the teeth are engaged in an appropriate manner. So once I separate them out, I'm going to go to the mate one more time and then go to mechanical mate. This time I will be choosing the rack pinion option. For the rack, I'm going to choose the length for the rack, and for the pinion I'll be using the bore of 1 inch spur gear. And in order to define the engagement relationship between the rack and the pinion, we can choose either of these two items. One, we can input either a pinion pitch diameter, or the other option is to input the number for the rack travel per 1 revolution. So we need to calculate that based on the pitch circle diameter by calculating the circumference and then converting it accordingly to input as per the rack travel per revolution. Either of these two options are fine, but before we do that, let's change the units to inches, because that's what the parts are designed with. I'm going to go to mates one more time, mechanical mates, rack and pinion. For the rack, I'm going to choose the length of the rack, and for the pinion I can choose the bore of 1 inch spur gear, and the pinion pitch diameter is equal to the number of teeth divided by the diametral pitch. So we know the number of teeth are 30 divided by the diametral pitch, which is 24, and that is equal to 1.25 inches is the pitch circle diameter. Click on the check mark, click OK, and then just try to verify if the assembly has been done correctly. So I'm gonna again look at it here, and if sometimes you see the problems like this, even though you were careful in terms of separating them out, it really doesn't look like it has done its job accurately. So what we can do is again expand the mates and modify the tangent option that we had selected. So I'm going to right click, edit feature. I'm going to use Control 1 to put it in the front view, and then try to okay, so it says it's smoked, it says it's fixed. So first I need to suppress the rack and pinion, and then edit feature on the tangent, and then I'm going to select the options here. So let's go here and then click on the rectangle face for both the rack as well as the pinion. I'm going to click OK, and then again edit feature, just make sure that that is accurate, 1.25, click OK, one more time OK, and then unsuppress it. And now if I try to do this, it should work fine. So sometimes these minor adjustments one needs to make in order to make sure that the assembly has been meshed correctly. That is how the rack and the pinion assembly created in the SOLIDWORKS. Thanks for watching this video, and we'll see you in the next one for the belts and pulley.